Hello, thank you for joining today. My name is Mike Stevens, and I'm an NC Applications Engineer for Adaptive Corporation. And I will be giving you a demonstration of CATIA version 5 NC programming. And on this demonstration, we will be focusing on knowledge-based machining. So we'll switch over to our CATIA session. And on the screen, you see our setup with our part and sitting on top of a 5-axis machine, which since we don't need the machine right now, we're going to go ahead and hide that so we can focus more on our actual part programming. So I'll zoom in on this, and what you see is a aerospace bulkhead type of part inside a stock on a backup plate with tool tabs on a tombstone. And that's what we'll be programming today. CATIA V5 uses what's called a PPR data model. You see here you have the PPR, which is a process list, product list, and resource list. The process list contains all of your NC programming, the product list contains all of the geometry, and the resource list contains your machine and any tools and holders you're using. So this methodology, it allows you, while you're in the NC session, you can easily come over here and you can do work on your design or your assembly that it's sitting in without having to go find some other application to do it. Just double clicking on one of these will bring you into that other application. But we don't need to go into the other application, so we're going to focus on our NC programming, and we're going to go ahead and grab some knowledge-based NC by selecting our catalog browser. And knowledge-based NC allows you to capture and reuse your strategies and the way you like to machine parts. So when you have things that you know are proven, they work, all the settings that are in them, you capture them, you store them, and then you apply them later, then you're not having to refill out all this information every time you program. It's there, and since you know it's proven, you know it's going to be good. So my main NC catalog has two different branches in it, aerospace and automotive. So we're going to be in aerospace. So when I open that up, I'll see I've got three different families in there. I've got brackets, ribs, and I've got bulkheads. Well, since this is a bulkhead type of part, I'll open it up, and it contains the operations or the processes, I should say, of what's going to be required to machine these type of parts. So I'll go into the one that's called main roughing first. I'll open it up and I'll see that it has a roughing operation, a cavities roughing operation inside of it. But you also notice this little URL button up here. If you click on this, you have the ability with KnowledgeWare to link any type of document you want to that. So in this case, what I've done is I've linked document that shows instructions on what this process does and how to use it. So I've got a couple different pages in here, and you can set these up any way you want to on how to use this. And I've actually done this at a couple different companies I've worked for where you had programmers who were not used to, they didn't build the processes, so they're not exactly sure of how they're supposed to work. I was able to put instructions on all of them, so they would just click on that and it would open up and they could use the processes that I had developed as if they knew them from the start. So that's a function you can do. So we're going to just tell this where we're going to put this in the program, and we're going to OK it. And then we'll close our catalog for now. And you'll see it's put a tool change in there and it's put the operation inside of it. So first thing we're going to do, the stock has already been machined down to the top, so we don't need to do anything with that. So we're just going to go ahead and hide the stock for now. So to do that, very simple. We'll come over in the tree and we can see it. We'll right click, click hide show, and now it's hidden. And you notice it under intensifies in the tree, so at a glance you can see that it's been hidden. So we'll double click to open up our operation, and everything is filled in here. I don't really have to do too much to this. I need to tell it what the part geometry is. And in this case, because we had all that extra stock out here, I don't want to machine all that extra stock. I'm going to put a limiting contour around it to limit it, and I'm just going to select the edges of the part to define the limiting contour. And now I can use my navigation tools. Okay, so we've got most of the work done that we have to do because of the knowledge based, but I want to make sure that I leave even amounts of material on the planar bottoms, so I'm going to add what are called imposed planes. If I right click on this, you can see there's a search view option, And then you have a choice to find all planes or just the reachable ones. Well, if I clicked all planes, it's going to find the ones on the sides here and the one underneath that you're not going to get to. What I really want are reachable planes. So when I click that, it then brings up the reachable planes. You can see that's the top, and then you can see the other surfaces there. We don't want the top, but we want these three. So I'll multi-select those, move those over, and now those will be imposed planes. Now, a couple of things I'll show you that came in by having this knowledge based. First, if I right click, well, first notice up here, offset on part of 50 thousandths. If I come over here and I look at offset on these, you'll see there's this formula icon. And if I open that formula up, you'll see that it's linked to the offset on part up there. So what happens is I've made this so that if this offset here changes, this will change with it. Let's go over and look at some of our other options here. You see the fully engaged toolpath management. I can click a little thing and you see a question mark there, multipass, and you'll see a formula here too. Now, if I come over to my axial depth, you'll see the depth here is 350 thousandths, and you'll see this is 175. That's because I've linked that by formula to be half of this distance. And this distance right here, you notice as a formula, that was defined in the cutter that was selected, as well as was the step over from the cutter was selected. So this is for an 1.25 inch cutter. If I change this, let's say to a 1/2 inch cutter, these values would all change and update based upon that cutter, and you wouldn't have to go in and change these things manually. We'll also come over here and we'll look at our speeds and feeds, and you'll see here automatic compute from tooling speeds and feeds. So it grabbed the speeds and feeds that were assigned to the cutter, and then by formula I've linked the approach and the retract feed rate to it as well. So if these change, if I turn this off, I can give you an example here. You see how the approaches and retracts change right with it. Okay, so all we have to do now is go ahead and compute our tool paths. Okay, the tool paths have been computed. And if you notice, this is using a zigzag strategy, but you notice they're all going in different directions. There's a cool little function called optimized, which when you do that, it analyzes the particular feature it's machining and then makes the tool paths cut in the longest direction of that feature. So if you had this set at zigzag and it was going this way, typically you would see it zigzagging in the pockets, but instead it makes it go, so it makes it more efficient machining. Let's run a video simulation of this. And you can see when you look at this, you can see the lighter cuts when it's fully engaged, it's cutting half the depth, and then the heavier cuts. I'm going to go ahead and speed this up. You've got this little slider here, which will speed up or slow down your tool paths as you need to see them. There's other controls in here too, but we're not going to get into those right now. Okay, so we're done roughing this. Let's do an analysis on it. With NVX, and it's included in AMG, I'm able to do this remaining material and gouge analysis. And the way this works is you set a tolerance value, and then you set the different steps you want it to be registered as in both gouge and a remaining material, and then you simply apply it. And what it'll do, it'll color code the part, and it'll show you like the top is already net, so you see that's green. And then you come over here and you look at the colors here, they're in the 50 thousandths range. Then you also have pick point analysis. If I click on this, it tells me what operation cut that area, what tool cut it, where I picked, what the plane is, if it is a plane, what the thickness of the wall is, and how far I away am from nominal. So if I see I got 50 thousandths, that's what I meant to leave. If I come over here and click on a green area, it's rounding error to nothing. So analysis is a pretty cool tool. You can move in, you can redo it again. It lets you see. Now, if you look, we got areas and corners that are going to have to be reworked, and we got some heavy areas and corners too. So let's go ahead and cancel this. We'll click this, which will save our result at the current level. So that tells me it's been stored. And when we exit out and we OK this, you'll see the little blue over on this. That signifies the video result has been saved at that level. So let's go back into our catalog again, and we'll go back into our aerospace bulkheads. And you see we have a rework roughing here. Well, we don't really need to do that on this part. So we're going to skip that. So that's an important point too. If you build these, you build them the way you want to, but there could be, from a family of parts perspective, there could be some operations that are applicable to certain parts and not to others. So if it's not applicable to the current part you're running, you just skip over it. So the next one we're going to go to is rib and wall tops. I'm going to open that up, and that has two operations in it: rough wall tops and angles, finish wall tops and angles. We don't really need this one, but since it's in there, it'll come over anyway. We'll tell it where we're going to put it. We'll open it. And just like before, I don't need this one, so I simply delete it. So even if you get something in there, if you have too much, it's easier to delete something than it is to start from scratch. So let's open up our finish wall tops and angles. And what this does, I define a part. By the way, before you notice, I don't know if you noticed it on the previous, you notice there's always 5 tabs across the top here. These tabs always represent the same type of operation in any operation you're in. So the information underneath these tabs is going to be the same type of information in every single operation you pick. So this tab here we're in is always going to be our geometry selection. The far right is always going to be our macros or approach, retract, non-cutting motions. This one is always going to be our speeds and feeds. That's always going to be our cutter selection, and this is always going to be our strategy options. So it makes it very easy to navigate through any of these type of operations you can do, because you'll always know where to go to set the strategies you need, or whatever it is you're selecting at that particular time. You'll also notice there's a traffic light system here. There's red lights, we have green lights, and there's a potential yellow light. So when you have a red light, you cannot compute cutter paths. It means there's required information is missing. Green light means all required information is there, and yellow light, which we don't have, but you could, means that it's made a selection for you, and you should probably go look at it. So we're going to go ahead and define our entire part here. So that's our part body. And then we're going to define the actual faces that we want to select. I have fat fingers. And we're going to do that. We want to get all these wall tops. So I'll simply select the bottom one here, and then I'll hit my navigate, and it goes and it finds the navigation. There's some other specific tools you can do that if it was a little bit more complicated to find it. In this case, we didn't need to. So we'll select that. And since this is knowledge-based, everything is set. All my strategy options are set. My macros, how I'm approaching retracting, is set. My speeds and feeds are set. My cutter's been selected. Everything came from our stored knowledge. All I need to do is hit replay. All right, so we look at the tool paths on this. We can see that it's doing multiple passes where it needs to Keller going up the ramps, but on the single passes, it is only doing, or I should say on the flat wall tops, it's only doing a single pass. So it's smart enough to know the difference between a flat area and a non-flat area, and we can run a quick video on this. Okay, so we're done there. Let's go ahead and we'll assign our video result at that level. So you see now it has a V as well. Let's go back into our catalog. And now the next one is rework vertical corners on rework area. Okay, so that's going to be those areas in the corners where the cutter was large. We're going to take some more material out of it, but I need to create a rework area first. So I'll go ahead and cancel out of this and come over here to the side, and you see this looks like what was in the picture, this rework area. So I'm going to go ahead and select the rework area, and I like to give these things names. So I'm going to say rework roughing corners. And what this does is it does an analysis. You tell it where the geometry is, you tell it what size cutter you want, or I should say the previous cutter, and then you say figure out where that cutter couldn't fit and then create guidance areas for me to go back and remachine them with. Now you can fill this out manually, but you can also use this load from button. So I'm going to click load from, come over to my roughing, and it's grabbed now the cutter, and it's also grabbed the geometry from that. So that's the easiest way and the recommended way to do it. I'm going to come over to my other tab, and I usually like to have an overlap. The way this works is it computes the rework area tangent to where the cutter stopped at, so you don't have any overlap. So I put a little overlap in there. And since this was on roughing, I'm going to add the same offset as I had in the roughing. So come over on my edit. What this is going to do is this is going to divide whatever angle I say areas into horizontal and the vertical. So I'm going to make the length a little bit, tighten it up a little bit, and then I'm simply going to compute. So this is now analyzing the part to that previous cutter, finding out where it can't fit, and then it's going to show representations of the area. So the red are the verticals, the blue are the horizontal. We're only going to be dealing with verticals. So you notice this one over here that had a lot of material is blues, considered horizontal. These are considered vertical. So looking at these, remember these three corners here had heavy material in them. So I want to use a little bit different strategy to machine those than I do the rest. And so what I'm going to do is when I select on vertical, I have the options where I can add or remove, I can divide, so I could break these up into other lines and then assign them separately. But what I'm going to do is add remove. And when I select verticals, that since I'm in the vertical set, it removes them. So you see it's turned them green and they're now in the remaining area, which is what I want because my process is going to look for remaining areas. If I wasn't doing knowledge-based machining, I could come over here and I could assign different machining strategies to all three of those levels, apply it, and it would put it inside my program. I would then still have to go set all my settings in there, but they would be in there and they'd be looking at just those areas. But for what I'm doing, I just need to say OK. And now to view that, I go into what's called our manufacturing view. And you can see it says rework roughing corners right there. And now this time when I apply from the catalog, I'm going to go back into my catalog, go to aerospace, go into bulkheads, and rework on rework area. You see it has two operations in there, rework corners, rework heavy corners. Tell it that's where it's putting in the tree. And now this time I'm going to select this as my geometry to machine. And we'll close this for, actually, I think I'll close it, come back to it. So we see we have the two operations here. And I'm just going to replay these. I don't even have to open them up. Okay, so you see it's reworking all those corners, and you notice the size of the step over on this. So it didn't do the heavier corners, and this, because it was horizontal, it didn't do. So now we're going to do the next one. And that's telling you that the macro, the way it was set up, could have caused a collision, so it automatically modified it to avoid it. And you'll look here and you can see the step down is quite a bit smaller. Actually, it's about 50%. So if we look at both of those tool paths at once, you can see the difference where we're doing more passes in the heavier areas. So we'll go ahead and run a video simulation of all of this. And we'll save that at that level. We still have to rework that corner over there. Let's go back to our catalog. And then I've got rework sharp multi-axis corner. So we'll open that one up. We'll tell it that's where it's going. We'll click OK. It's now put inside. Now this is what's called a multi-axis flank contouring operation. I'm going to open that up. And we're going to do fixed axis on this, but we're still using a multi-axis because it happens to lend itself better for this particular application. So what I need to do, you notice how this, again, you got the red images. If I can have it start in, on, or out, or tangent drive surface, and you can see how the symbol changes for you. We want it in. Same thing on that side. Actually, these I'm going to make the same size. On other parts, they're different. This one, I think it's going to be better if it's the same size. So you simply double click on it, you change it. And that's a good point to make, that even though this is coming from knowledge based and you're having it come in with everything set, you have total freedom to change any of those settings because every time isn't exactly the same. So there will be times where maybe you want to have it a little bit different. So with this, I'm going to go ahead and select this wall as my start, that is my stop. And then I'm going to select the walls I'm going to be driving here, which are just these three. And then I'm going to select the bottom. So once again, this being knowledge-based machining, that's all I need to do. And let's slow this down and we can run our... All right, let's run a video of that. This one we used a different strategy because it was a sharper, because we wanted to have more radial passes with it. But now we've reworked that. We've got all the corners reworked. We can start doing some finishing. So we'll save our results there. Go back into our catalog. And then our next operation is going to be finish inside walls and floors. This has two operations inside. Okay, it has a an advanced finishing operation and a multi-axis flank. So we're going to put it after this. And now the advanced finishing is a global operation where it'll machine floors and walls and finish them in a kind of a meltdown type of application, and it'll do it on 2.5 axis walls or 3 axis with Z. So you cannot do canted walls with this, but it comes in very handy for certain ones. So in this particular case, I have 5 pockets that are 2.5 axis walls on it. Then I have 5 that are 5 axis. So we're going to concentrate on these. And all I need to do is select the bottom face in each one of these pockets. And then I can use my navigation tools. It found in all the other adjacent walls. And again, for this one, all I need to do is say OK. Okay, we have the same type of thing. A macro has been modified. There's all our tool paths. You can see it knows it cuts, doesn't cut across where it doesn't have to, cuts all the bottoms and pockets. So let's run our video of this. And I'm going to go ahead and speed this up again. Okay, so let's run an analysis again. And now we can see everything's green except for the five axis pockets. Okay, so now the next one is finish multi-axis walls. This again is a multi-axis flank contouring, and we're going to end up copying and pasting this to do all 5 walls. So it was only put in the catalog one time because the bulkhead type of parts, they vary, so you use it once and then you copy it as needed. For right now, I'm going to hit my F3 key. That hides my tree. F3 turns it back on. And over here in this looks the same as the other one. This time we're starting on. Now I want to start and stop. I'm going to go all the way around the inside of these pockets. So I want to start and stop in the middle of a wall. I could go build some geometry, some points to select on, but what's kind of cool is when I do my start point, if instead of selecting a surface, I select a line, it automatically puts the start point right in the middle of the line I selected. Same thing for the stop point. So now I can grab my geometry. I'm going to show you a few different ways. This one, I'm just going to manually walk it around. And you just grab your surfaces in order. Tell it your part surface. And then go ahead and replay it. Okay, I can walk my cutter around and look, but you also have some other visualization tools here. I'm going to go ahead and turn my axis vectors on. So this shows you the interpolation as it moves. Now this is using what's known as a Tantu fan strategy. So it does a smooth, even fanning from its start to its end point on any particular surface. So in this case, the 5-axis is really over here, and I really don't need to have it fanning all the way across there. So we're going to change that strategy. So where would I do that? My strategy tab under tool axis. Again, very logical. What is it I'm changing? My tool axis where it's a strategy. So there it is. Tan to fan. Again, you get these little question marks that help you. I'm going to click this and I'm going to change it to Combi Tan2, excuse me. So you can see here it's showing the fanning motions and then it's showing the straight motion between. And with this Tan2 fan, you can have a leaning and a leave distance and an approach distance. So again, I can click the question marks. So you can set a guidance as to what it tries to do the fanning in that distance. So you see now we're getting it as fanning over here, but now on the straight walls, it's not fanning. So it's a better strategy for these type of pockets. So I'll leave that. Let's actually, you know what? We won't run video now. We'll do a few of them first just for time's sake. So now I've got this and I want to go ahead and since I've changed the strategy, I want to copy and paste it for all the others. So I'm going to go into my tools options and opened up on the other screen, sorry. So I'm going to come over here into machining under operation, and you see this duplicate geometry links. Well, if you don't know what that does, if you click this help question mark here, you can click this and it'll tell you. So what it's telling you is that if I have that checked as it is now, and then I copy and paste it, when it's pasted, it'll bring all the geometry that was selected with it. In this case, I don't want that, so I'm going to turn that off before I do my copying. And with CATIA, you have full Windows type of shortcuts. So I'll show you one way, then I'll show you the Windows shortcut. So I'm going to right click on this and I'm going to come over and copy, and you notice it says Control C. And then I'm going to come over here and I'm going to paste, and you see it says Control V. So now I need 3 more of these. I'm just going to go Control V, Control V, yeah, it doesn't matter, Control V. So now I've got all the operations to clean the other ones. And so we'll open up and we'll just go assign the geometry to them. So we're going to do it the same way we did the first one. I'm just going to grab those as a start and stop. This time I'll show you one of the navigations. I can say navigate until a face, and it selects all the faces in between up to that one. Then I can select the other ones, and we'll select our bottom, replay it. So you see with knowledge-based and see how quick it is to machine things. I don't have to go through and set everything up because it's already stored and done. Saves you a lot of time programming, and it also makes it safer because you know these things work. You've proven them before. Okay, let's do the next pocket. And same type, we're going to come over and we're going to select our starting and stop points. And now on this one, I'll use full navigate. So it navigates around until it can't find its way for whatever reason. And then I can select the other pockets, or excuse me, the other surfaces. And we'll select our bottom, compute that. So I'm going to go ahead and turn my vectors off at this point. Yep. Turn it back to non-vector display. And let's go ahead and run a video. We'll run a video on those last 3 we did. So you notice this, you don't have to run a video every single time. Oh, I didn't run it back there either. Okay. Oh, you know what I did? I didn't save it at that level. So now we get to watch all of this done. So it starts where the last time you saved the video result at. Okay, and if I want to do a quick analysis here, Okay, we can see our results. Everything's green where we expect it to be. You see these little areas like that? That'll get cleaned up in the next operation. So we will cancel that, and this time we will save our video results. And we're now ready for the next one. Now the next one is this steeper pocket wall. It's the one we had the special rework for. So, but we'll machine it the same way. I'm going to show you one extra little thing I'm going to do when I machine it though. And we'll use our navigation. And you can actually, the next one, you could click that and you can navigate it too. But this time, just because of the steepness on this, I'm going to give this an auxiliary guide curve. So I'm going to select this top. And what that means is the cutter cannot violate that. Okay, so we'll watch this run around. Let's run video of this. Okay, that looks good. Let's do an analysis of it. And one other thing when we do after the analysis here is done, okay, you can see nice and green all the way around. And we won't forget to do that. But let's say just because, let's run our regular replay again. And you notice the cutter is leaning over quite a bit. So here you might have a concern, you might have some machine interference. Is the machine going to be able to do that without colliding with everything? The nice thing about being able having your machine simulation and having your machine here, I'm going to go pull my machine back out so we can see it again. And with that operation, I'm going to go ahead and I'm going to say start machine simulation. So what this does is this switches us over to the machine simulation workbench, and now we can simulate our machine. So this is a nice feature in the fact that you can do, and I'm going to rewind that. We'll run it again and slow her down a little bit. So the nice feature about this is I didn't have to post the job or anything at all. I'm in the middle of programming. I have a concern and I'm thinking, is there going to be any issues with the kinematics of the machine in this? You can immediately simulate it on the machine ahead of time before you even get to where you're going to post it. So it's a nice feature. At any time you want to, you can stop and and I could have done it on the entire program for that matter, but I didn't have concerns anywhere. This is the only place I had concern, especially with that backup plate out there. But we notice it's running fine and it's not going to hit anything. But again, it's nice being able to check this live without having to get to the very end and then finding out you might have issues. Okay, so we'll end that. I'm going to hide my machine again. And then I simply exit out of this and it brings me back into my advanced machining workbench. So now we'll do the last one. And this is going to be the same way. Grab that, grab that. And then that time it found its way all the way around. Hit this and compute. And we'll do a quick video. All right, let's save that at that level. Okay, so now for the next section, let's go back and just look at our catalog here. You can see I've got mill floors net. And this has 3 different operations, 2 pocketing and 1 profile contouring, mill closed floor, mill open floor, and then finish open floor walls. Well, we're going to apply these a different way because we're going to predefine some geometry and then we'll be able to apply this process on all the geometry at once, and we'll let some rules that were established when we built the process to determine what's an open and what's a closed pocket and what operations it applies. So first thing we're going to do is we're going to create what's called a prismatic machining area. And I'm going to call this closed floor, and I'm going to capture this with a Control C because I'm going to reuse this name. Close floor 1. Now you notice it says open pocket. When I click it, it changes to closed pocket. And then I'm simply going to select that. It grabbed all the geometry. So I've created one prismatic machining area. I'm going to create another one. I'm going to create 7 of these actually. So we're going to call this closed pocket 2 or closed floor 2, which will be this one. Then we'll now see doing this is when you're doing this, you're going to have to select this geometry one way or the other to tell it how you want to machine it. So by doing this, we're going to save quite a bit of time. Okay, so now I'm going to go ahead and define 2 open floors. It is a pocket, but I'm calling them floors. Open floor 1. Well, let's grab that first. Control C, and we'll call that 1. We're going to leave it on the default open, and we will select that. And you notice the dashed edges here. That's what defines it as an open pocket and means the cutter can go beyond that edge. The other ones are hard boundaries. These are soft boundaries. So that's going to be open floor 1, and then we will do open floor 2. Okay, so we've defined 7 prismatic machining areas. We go to that same manufacturing view to see those. I'm going to sort by machinable features, and these features, since they're linked to the design part we selected, they're going to be listed under it. So there you can see all of those features I created. Now, instead of going back to my catalog and applying the process, there's another way too, this Machining Process Application Manager, and it's actually quicker. It doesn't show you the images and it doesn't show you the links to the document if you have it, but this is more when you get used to it and you understand this is a much quicker way of doing it. You see, it opens it up. I'm in the same catalog, but all my processes are listed here. I didn't have to go through any menu selections. And you can see the mill floors net right here. I can select this and then I can multi-select all of these and they're put in there. Tell it I'm going to put it there in the tree, and then I simply say OK. And what it's going to do is it's going to apply that process to all 5 of those features, and it's only going to assign the closed pocket operation to the closed pockets and only the open pocket to the open pocket ones. So you see they're all inside here. I'm simply going to replay those. Closed floor. So it's doing the first one. You see it's doing a helix down to the bottom and the circle off coming off. So I'm just going to hit the forward and it's going to do all the closed pockets like that, coming all the way to the walls. And now it's going to do open floor net. You notice how it's staying away from the wall, and then the profile to finish it. And the reason why is when you have this type of an open pocket, especially when it goes out like this, you can end up leaving a little bit of material. So by having it set that way on our knowledge base, it automatically comes back and does a pass around to make sure that gets cleaned up. Okay, so all those floors are done. Let's go ahead and run our video. And let's do an analysis on that. Okay, we can see everything on the inside is green, except you can see the holes, those little dots there. That's where the holes haven't been done. So that's what we're going to do next. Save our video at that level. So we're going to stick now with our machining process application. But first, I'm going to define a machining pattern. So I'm going to click on that. I'm just going to call this top holes. And another cool thing, I'll show you this. This is where you select your geometry. If I put my cursor on this and I right click and say center graph, it brings me right to the tree to where those design features are at. And I have 2 different patterns of 1/8 holes. So I'm going to select both of those here. They're all assigned now, has them all inside. So now I've created that feature or machining pattern called top holes. And that again is accessed through our manufacturing view. You see it's right here. And we'll come back into our machining process application manager, and you'll see spot drill and drill. We'll select that. We're going to put it here and we're going to select that pattern. Okay, so it's created the two operations, spot drill and countersink. It's coming down and it's countersinking also. That's the way it was set to do in the process, to look at the diameter, and then it's going to drill. We'll slow this down when we video it because it moves pretty fast. And you see spot drilling and then the peck drilling motion to drill the holes. All right, so we've got that done. The only thing we have left is to finish the outside and leave tool taps. So we'll come back to our machining process application. I have a rough and finish outside walls. I'm going to put it there. And in it came three operations: rough and finish outside multi-axis, rough and finish 3-axis to the tabs, and then finish between the tabs. So we have one multi-axis wall on the outside in this case. So this, and you notice the settings are different. Again, it's a multi-axis flank. I'm going to select that as my start. And now the stop in this case, it's another thing. I don't have to select a surface. And because of this angle, I want to make sure the cutter goes all the way beyond it. So I'm going to select that tip there as my stop point. This would be my only drive surface. And then instead of selecting this channel here as my bottom, if you do that, since you're canted and you're cutting under that, depending upon your radius, let's just take a look at our tool here, you could end up actually having your radius up on the wall. I'm going to show you something on that. So instead of doing it that way, I'm going to come over and I'm going to right click on this and say use curves as part. So I'll select that. That now makes that curve the part surface. And what it does is it puts the cutter so it cuts right at that tangent point at that curve. That combined with I have a negative offset of 50 thousandths means that this will cut 50 thousandths below, which means you're guaranteed to have 100% cleanup on that wall. Now I know what's going to happen when I click. Let's get to the other screen. Click replay. I get an error message. Not an error, an information. What that's telling me is it can't find where it's supposed to be at. And it gives you some options of what to go back and try. The reason why is this, you see a start and I'm saying I want to start out. Well, it doesn't know what out is. And the reason why is because this happened right after a tool change. It didn't have another operation behind it where it can look and see where that tool left off. Because it came from a tool change, it doesn't know what if out is on this side or out is on that side. So I can come over here and I can give it what's called a reference point, something that'll guarantee it's out. So what this does is it now looks from here and says, okay, that wall out is on this side. So now I hit this, it'll compute. Okay, so what this is doing is it's spiraling down. It's doing the first pass and it's doing it at a machining feed rate. It's doing it at a reduced machining feed rate. You can see that's 150 inches a minute when it's doing full. And then on the finishing, it's going at the full 300 inches a minute. So let's run our video of that. So you see it spiraling down, helixing down to the first level, doing a full depth, then a finish pass. It's going to do that each way on the way down. All right, let's roll her around so we can see 100% clean up on the bottom there. Okay, so we're done with that. Let's save that at that level. We'll go into our next operation. So this, what we're going to look at next is what's called a profile contouring. This is in this particular setting is a 2.5 axis operation. Works very similar. You notice the picture's a little different. It's not a canted wall because it's 2.5 or 3 axis. We're doing it 2.5 right now. So I'm going to select that corner as my start point. And I always like to select the start and stop first. It doesn't really matter what order you do it, just a personal preference of mine. And we'll select our edge and our edge here, and then we'll navigate. Okay, found it to the edge. And now our part surface in this case is just going to be the top of the tab. And this one, I also want to give it a top, which will be this. So this is doing the same type of thing on the other wall, except it's ramping down. Over here we had that opening from the first one, then it ramps down each level, and it's going and cutting at multi-levels coming down. And we won't run video yet. Let's run the last one. The last one is rough and finish outside 3-axis walls. This again is a profile contouring, but you notice how the image has changed. You have multiple options. What I had the first time was between 2 planes. I can also do between 2 curves. I can do by flank contouring, or in this case, between curve and surface. And you notice how the images change to make sense to what you're doing. So we're going to select almost the same geometry. We're going to select the same start and stop point. And we're going to select the same drive geometry. Navigate. Okay. And this time, since this is a surface machining, we're going to select the bottom of the tray in the backup, and then we're just going to select the top of each one of these tool tabs. And then I'm going to navigate, and it finds the curved surfaces as well. So let's hit our replay on that. And this picked up where the last one left. So let's go ahead and run. You notice how it's riding up and down. And it's doing the same thing, doing a roughing pass and then a finish pass. Yeah, I'll tell you what, I'm going to slow that down a little bit. Oops, still slower. There we go. And you can see it going up and down over the tool tabs. Okay, and so our part now is 100% machine and machined 100% from knowledge-based programming. That concludes the demo. Thank you for watching. I hope it was informative for you. And if you have any questions, feel free to ask, and you can ask an Adaptive Corp representative. I'm not easy for me to say. Anyway, thank you and have a great day.